individuals to become a smarter, right? To become a future workforce. We help with various different programs. We do codeathons, we do hackathons, we do meetups, basically to help you guys to understand 360-degree of intelligent technology and the future technology, and become smarter in the workplace that you do as an intrapreneur or as well as an entrepreneur, right? So that's the goal of Testoper community. For those who do not know, you can always go and look up website Testoper at testoper.com, and you can go to YouTube Testoper. There's a lot of videos that you can see the training that we have done. You can go to Eventbrite, search for Testoper. You would see the future programs that we have that you can register with, right? So now within Testoper community, we use Microsoft Teams for the collaboration. So I see today Josephine, Joy, I don't know why always it looks like, and Krutark, and I'm looking at here, Ogo Lyle, as well as SG guest, right? So all of you have joined directly by clicking the link into this program. But if there's a couple of things that you would see in the chat. One thing is our team will put the WhatsApp link. It's a closed WhatsApp group that we have for the Codeathon learners, just to communicate the important news, like the change in the schedules and stuff like that. And then the second thing is we use Microsoft Teams, like I mentioned, for collaboration before and after the program. Those who wants to have an account, Microsoft Teams account, please send your email addresses. We will add you into that account, so you normally will have access to the teams that we use, right? So I'm sure that you all might have heard of Slack and so on, right? So likewise, we use Microsoft Teams, as you can see here. So once you have access, you will get access to different channels, and you can collaborate with the people before and after the event. So we have mentor-mentee channel, study group, people come together and study together. We have tech teaser, people put some topics and people respond by themselves, right? Then we also have job channels where different community people come and post their own jobs here, right? For those who, so basically it's a collaboration platform. And once you have access to this collaboration platform, then you can also access all the presentations that we use for the different programs, going into the files, for example, IA track, and you can actually see all the programs and everything that you would see here, and also the videos in the YouTube. So having access to this Microsoft Teams of Testoper community will really help you for the collaboration. Not only help you, help all of us, because it's all run by all of us together, helping each other and learning each other and growing each other. So that's what we do at Testoper community. And again, it's a non-profit. It is not run for profit. Any support, referring to your friends and referring to your employers for sponsorship to run the shows and so on will really be appreciated, right? So with that, I will hand over the floor to Ahmed. Ahmed is our session hero, and this is his second session on Kubernetes and microservices and Kubernetes topic. And he would be taking 3 more sessions. And the idea about this session is basically, give you a fundamentals understanding of Kubernetes and microservices, and to an extent, show you a direction how you need to actually evolve yourself in this particular topic. Of course, this is a huge topic, but this is what we are starting with for a 5-week session, and today is the second week. But in future, we will try to come up with more dedicated sessions on particular topic in this big ocean of microservice and Kubernetes, and we will announce that in Eventbrite. Keep a look at it to register as you see the right event for yourself. With that, Ahmed, over to you.
Thank you, Kader. Good morning, everyone. Hope everyone's doing well. I'm glad to be here, trying to give back to the community, and hopefully, everyone will benefit from what we're sharing. As Kader mentioned, this is the second session. Let me begin the presentation, and just a second. Let me know once you can see my screen. Just a second. Are you able to see my presentation?
Yeah, I can see it.
Okay. So yeah, this is the second part of a 5 presentation series over microservice and Kubernetes. This time we'll actually start diving into Kubernetes, pretty much the basics of Kubernetes and the basic concepts of it. Just a little bit about myself. My name is Ahmed Harb. I have over a decade of experience in mainly Linux system administration, cloud, DevSecOps, automation, and in the past 4 years, containerization and microservices. I'm the founder and owner of Code the Cloud. I also work through ObjectSharp as a senior cloud and DevOps consultant. ObjectSharp are a Gold Microsoft partner. It's an amazing company to be working through. And I have also included my LinkedIn profile link in here. If anyone is interested or has any questions to ask, feel free to send it through, and I will answer as my capacity allows. I will start with a quick recap of what we have discussed in the first presentation. In part one, we mainly focused on the difference between microservices and monolithic design. Again, I cannot cover all the details there, but I believe, Kader, the presentation is available on YouTube. The slides were also shared. Everything is available through the Stopper community for anyone who would like to revise it. And if you have any questions, feel free to ask on the Teams channel dedicated for this Codeathon. Additionally, we covered what containers are, a high-level definition of them, and the role that they play with microservices. We delved into Docker as a container runtime, particularly also a bit on how to run containers with Docker, how to build images. And we concluded with the fact that we pretty much need a container orchestration if we're going to go to production with that. We cannot manage containers on our own, maybe at a small scale of 50 up to 100, but what if we need an actual production grade system? And as I mentioned, I shared this very famous tweet about Kubernetes that, someone tweeted saying that one time I tried to explain Kubernetes to someone and we both ended up not understanding it. So it's pretty complicated, but I'll do my best to avoid that. And the complexity of Kubernetes, in my honest opinion, is definitely worth it. I would like to share some information about the current state of Kubernetes and its popularity in the world of technology. So first of all, I have included all the links to the detailed surveys and reports. You can feel free to go through it. The recent VMware State of Kubernetes 2020 report, it surveyed, I believe so, around 250 individuals who are using Kubernetes. And this is all for companies that are 1,000 or more employees. So we're talking about big companies. And pretty much the Kubernetes usage since 2018 to 2020, in 2 years, has increased pretty much double from 27% to 48%. That's a huge jump for a single technology in very large companies, more than 1,000 employees. Usually it's difficult for them to delve into newer technologies, especially something as complex as Kubernetes. Additionally, there's a survey by the Cloud Native Computing Foundation, the CNCF, which pretty much Kubernetes is their project. It's under them, and they are under the Linux Foundation. So in the most recent survey, 84% of the respondents are saying they have admitted that, or not admitted, but have they officially stated that they are using containers in production, compared to only 23% in 2016. Again, within 4 years. And I think the survey was towards the end of 2019. So let's say 3 to 4 years, that's a huge jump. That's also nearly 4 times people using containers in production. And to use in production, that means you need an orchestration system. Whether a Kubernetes or something inspired by Kubernetes, it's definitely, there is an orchestrator in there. And again, the same report states that 3 out of 4 in these firms, so 75% of them are using Kubernetes. So pretty much at least half of the production deployments of containers are on Kubernetes. Additionally, Red Hat have their State of Enterprise Open Source report for 2020, and they asked around 950 IT leaders, and 56% of them expected even a more increase in the use of containers in production. So it's definitely worth it. It's definitely the #1 container orchestration tool out there, and it's definitely worth the effort to learn it and delve further into it. And all of that is done by Kubernetes in just over 6 years. Kubernetes is just over 6 years old, and back in June it became 6 years old. However, you'll still find some job, and this is a real job offering that's out there, a job description from IBM, where they're asking for someone who has 12 years experience in Kubernetes. So don't feel that I don't have any Kubernetes experience, or I only have 1 year. Even 1 year of Kubernetes is worth a lot, because that's 1 out of 6 years, to be honest with you, compared, even if they claim that there are people out there who might know more than 12 years in Kubernetes. Okay. So let's start with Kubernetes. What is Kubernetes? Why do we want to use it? And how we can start getting into it. Okay. So first of all, the meaning of the word. It's a very strange term, but it's pretty much a Greek word. It's pronounced as Kubernetes. It's the Greek word for helmsman or pilot. Geeks between codes call it Q8s, and 8 stands for the 8 letters between the K and the S, and it just follows the aquatic theme of the whole. We covered this in the first presentation. It just covers the whole follows the aquatic theme of containers, and all other tools even around Kubernetes and containers have always tend to always follow the aquatic theme. Okay, so in short, it's Greek for helmsman, captain or steersman, pilot, navigator. And in a short summary, it's pretty much an enterprise-grade open source container orchestration system. Okay, as I mentioned, it inherits the aquatic theme from containers in the name and the symbol of it as well. Originally, it was designed by Google. It's based on their Borg system. And in June 2014, they made it open source and donated it to the Cloud Native Computing Foundation. I believe it was the brains behind Kubernetes are 3 people. One of them is one of the most famous people is Brendan Burns, is actually now a corporate VP in MS, and he's handling several things, including Kubernetes in Azure. And you will find a lot of presentations by him online, and he's like, no one can explain it as good as him. And I would really suggest you look him up and look into all the articles he has posted about it and his videos. You would benefit a lot. And Google used their Borg system to spin up billions of containers every week. They have been doing this from, I believe, nearly 15 years now, and Kubernetes came out of that and became an open source system. And when it became open source, it benefited from a bigger community support around it, where now companies like Microsoft, Red Hat, all these huge companies are innovating more and more around Kubernetes. Okay. So it's designed with one main purpose, which is to automate deployments, the scaling, and the management of containers, containerized applications across a cluster of hosts. So you pretty much, and it abstracts that infrastructure for you even further. Okay, you have VMs, but it makes them very abstract for you, and you can just use them, and it makes it very feasible for software developers to use this cluster of hosts as just in an abstract way which would allow them to be much faster and have much more efficiency with what they deploy, or the ability to deploy. So you pretty much give it a group of VMs, and it will transform them to just a unified API service that the developers can interact with. It makes it very abstract and very easy. The popularity of Kubernetes, again, to continue on that, the first stable version, the version 1.0.1, was released in July 2015. It actually is a very fast-moving technology, to be honest with you. Every 3 months, there's a new minor version with the new features coming out, and even further, more other features coming out in alpha or beta, other than just things going to general availability or to the stable release. So since the version 1.2.0 in March 2016, they have followed this 3-month release cycle. Okay. The most recent version is 1.18, and 1.19 is actually expected in a few days to come out. So by the end of the year, we will have 1.20, or maybe 1.21 just in the beginning of the new year. I've linked the repo to the Kubernetes project. It nearly has 70,000 stars, 25,000 forks. It's open source. A lot of companies, a lot of people have taken Kubernetes source code and changed it in ways that work better for them as they wish, or they've built commercial solutions around it. There are nearly 35,000 developers who have contributed to it. There are over 180,000 commits. It's one of the top, if not the top, and most discussed repository in GitHub, pretty much. So why do we need Kubernetes? This is a slide from the previous presentation, and I just added it here because it pretty much, Kubernetes is the answer for all of this, okay? We don't only deploy one microservice. We always have microservices. We need Kubernetes to do that. When it comes to the resource allocation, to the state of these hosts, okay, what if a host goes down, right? Let's say a container goes down, another container needs to be started. Who's going to do that for you? Are you going to look at that? You should not, right? Containers should be treated as you know, the pet versus cattle kind of thing, right? They're not your pet. They are more treated like cattle. One of them going away does not impact the whole general picture, right? You need a system to handle that for you, because you will have, like Google, for example, they have billions of containers. They don't have hundreds or thousands or even, you know, tens of them. We're talking about who's going to look at every one of them or even keep track of that. It has to be a system doing that for you, right? What if a node or, you know, we're abstracting these VMs, we're abstracting these nodes. What if one of them goes out of service, right? All the workloads on it, so all these containers on it have to be moved. Who would do that, right? You'd have someone to wake up at 2 a.m. and do that for you. That's not feasible at all. It's not like bringing up back a VM like in the old times, 20 years ago, let's say, or 15 years ago, when, yes, you'd have to stay up in the data center in the middle of the night to fix what's going on, right? VMs help, but it's not the same, you know, when you're working with containers, because you don't have the same number like VMs, right? VMs, you might have hundreds, but containers, you're definitely going into thousands, if not more, of production, right? So it would definitely be easier to be handled by a system. That system is Kubernetes, pretty much, right? Additionally, the scaling of this, the fault tolerance, high availability, having multiple replicas of your containers, the connectivity between these containers, right? How do I make sure all my microservices are communicating when they need to? The service discovery of that, the routing between them, the load balancing. If one of my containers is getting too much traffic, I need to make sure the traffic is, another one is added, and then the traffic is load balanced among these. Who's going to do that? Kubernetes will do that, right? The configuration of these containers, we're talking about billions, right? Maybe every 20, 50 of them have different configuration. They need different secrets to connect to DBs or whatever, you know, requirements from in terms of that. How will you provide these to that system, right? It's not reasonable to have billions of containers connect to a configuration. Let's say all of them, you know, pulling a GitHub repo, for example, where you have your properties and your secrets being pulled from a key vault or a vault somewhere. That's also not reasonable, right? You need to have a system that allows you to provide that to your containers. And if you want to do any update, you can also seamlessly do the update to your containers through that same system, right? What about the storage, right? Dealing with storage with containers manually is a big hassle, right? You need that abstraction layer also that allows you to deal with the storage, especially in the world of the cloud. Every cloud is different. Every type of storage is different. Even on-prem, right? There are so many types of, there is Ceph storage, there is ClusterFS, there is NFS, SMB. There is a lot of types of storage out there, even on-prem. And in the cloud, it's even more, right? Azure disks are different than EBS and AWS or Google disks, or even in Azure, you have Azure File, for example. Everything is different. You need that abstraction. It just in Kubernetes gives you that as well. It becomes pretty much an API that you communicate with, and that's it, right? Of course, there are differences on uniqueness for each one of them, but like NFS can be read, write many, right? A disk cannot be read, write many. So there are these differences, but you have an abstraction and ability to communicate with it with a certain template and a certain standard. Okay, and plus the general operation tasks, right? The management of things, the monitoring, the authentication authorization, who has access to what container, who can use what container, how do I monitor the state of these containers? I care about the performance. They're pretty much running my application, right? So I don't care about one going away, or should not care about one going away. I have the self-healing system, which is Kubernetes, will bring it back. But at the same time, I need to make sure they are working and performing in a proper way, like any other application. We need a system to do that. Kubernetes gives you basic monitoring, but gives you the ability to monitor further. We will get to that piece, but for the management perspective, it all can be done through that single API on Kubernetes. The authentication authorization also through that single API. I'm not talking about the authentication authorization to your actual application. I'm talking to the management of these containers, right? So if you have multiple teams collaborating or using the same Kubernetes cluster, you can give each one of them a part of it, or each one of them an access to a specific, deployments or pieces that they need to have access to, and avoid any overlap. Right? So what does Kubernetes provide? It provides you the framework to run these distributed systems resiliently. Okay, it takes care of scaling, failover of your application. It provides you deployment patterns and much more than that. Right? It provides you the service discovery and load balancing. Kubernetes can expose a container using a DNS name or using their own IP address. If the traffic to that container is high, it will scale out to another one. You can configure it to do that, or you can do your scaling yourself. But through that service discovery, that high level abstraction within Kubernetes as well, it will automatically start distributing the traffic to that pod, to that additional container that you have brought up, right? And it will make sure that way you will make sure your deployment continues to be stable and your application continues to perform properly, right? So it also provides your automatic bin packing, right? So it provides you with a cluster of nodes that you can use to run your containerized tasks, and you pretty much tell it how much CPU, how much memory you want to give each container, whatever it needs, and automatically Kubernetes will fit it on the nodes that make best use of your resources. It's designed to work that way. Additionally, you can leverage Kubernetes for automated rollout and rollbacks. So if I deploy a certain image of my container, if I want to roll out another one, there are ways to use Kubernetes to have a strategy on rolling that out without any downtime, and at the same time rolling back in case of any issues, also without any downtime. Okay, so it's also self-healing. So you pretty much you describe the desired state of what you want to deploy of your deployed containers using Kubernetes API, and if any change happens to that desired state, right? Let's say one container fails, then you can automate Kubernetes using deployments. They're literally called deployments Kubernetes. It will create new containers for you, right? So you can also use it for removing any existing stuff. You can also control the resources they're having. All of these pieces become abstracted to you through one API, which is Kubernetes. Okay. Additionally, Kubernetes, for example, is also self-healing, right? Using certain probes to your containers. If one of them fails, you can restart that container, right? It will kill that container if it doesn't respond to a specific health check. And additionally, you can also have some probes that it will not consider that container ready till certain things pass. Right, so it will not even advertise that container to your clients till it's ready to actually serve traffic. So you can build your own health checks in terms of that my container will not be considered ready and no traffic will be routed to there by Kubernetes till it passes a certain check. At the same time, if it fails a certain check, that means this container is in a deadlock of some kind. It needs to be restarted. So Kubernetes will do that for you as well. We're talking in the scale of thousands or tens of thousands of containers. No one will see that. You need a system to see that for you, which is Kubernetes, right? But that doesn't mean that you don't configure that system. You have to configure that system, of course, and build the logic around it. But it's very easy and abstracted from a Kubernetes perspective once you get a hold of all the concepts. Okay. Additionally, Kubernetes, it allows you to automatically mount storage as well, right? It helps you with the storage orchestration of things. Because it has this abstracted API, you can mount a storage that's needed, whether it's a local type of storage or a public cloud provider that gives you that storage. It's abstracted for you based on certain standards, and you can mount that required storage for your application, because not all applications are stateless. You need state. For state, you need storage. Or if you want to share files between your application containers, that means you need some kind of file share. You would use Kubernetes to do that as well. So all the components you need for your system or any typical application to run, Kubernetes pretty much has an API of some kind to cover that, and it keeps evolving. As I mentioned, every 3 months, new update. Every 3 months, new things are supported, new things are added to it, new features are added that answer more and more of the complexities of the modern application development needs. Right? Additionally, secrets. Right? Applications need certain secrets. You have TLS certs. You have auth tokens or passwords or anything that's being used. Right? SSH keys, for example, if you're going to be using for some connections. So you deploy and you update your secrets, your application configuration as well, without rebuilding your image, right? You should not. First of all, it's not a security. It's a very bad security approach to actually bake the stuff into your container image. That's not good, because someone gets your container image, they pretty much get your secrets. That's not good. Plus, from a microservices best practices, you need to separate your application from the configuration, because if you don't do that, then pretty much none of your applications are stateless, because you're baking that into it, right? So your application should be running without any secret or any configuration or properties baked into it. You pass that along at runtime, and it goes away when that container goes away. So nothing is ever saved, right? So Kubernetes, again, gives you the API to do that. There are config maps, there are secrets. We'll get to all these parts, probably not in this presentation, in the next one, but we will cover all these components in details as much as possible. But the summary is Kubernetes gives you also the API to handle that, and the ability to update it without having to update your actual image of the container. So you don't have to go through the whole build cycle again. And so this makes it very, very fast. Let's say something is discovered that one of the secrets that were passed is wrong and you're failing to connect to the DB, you just have to update that piece of it, right? And then your application will be healthy and running without having to go through the whole build cycle and the delays that might incur. Okay, it's also important to note what Kubernetes is not. Okay, so Kubernetes is not a traditional all-inclusive platform as a service or a PaaS. Okay, it operates at a container level rather than the hardware level. It does provide some generally applicable features of your common PaaS services, right? Things that like other PaaS services offer, as I mentioned, like deployment management, scaling, load balancing. These are things that typical PaaS services also offer to you. But Kubernetes lets the user integrate their own logging or their own monitoring or their own alerting solutions. So you have also the plugin part of it that you have to work on, or you have to put in there. So it's not an all-inclusive PaaS. It doesn't have everything in it as a platform as a service, but it is a platform for container management orchestration. Okay. Additionally, to summarize it, also Kubernetes does not focus on specific services or specific applications that it can only support. It's not built in that way. PaaS solutions usually will support specific stacks, right? You have certain stacks that you can deploy. Some PaaS solutions might have a big variety of stacks, but it's never all of them, okay? Kubernetes, if you want to think of it, is for application support or application stack support. It's pretty much what Canada is to the world in terms of diversity. So whatever you want to run, whomever wants to come to Canada is welcome here, right? In this country, we're all happy to be here, and we're all lucky to be here. It's the same on Kubernetes. Any application or any stack you want to run is welcome on Kubernetes. There are very rare cases where things would not be feasible to be deployed on Kubernetes, or it's not the solution for everything. I'm not saying that. In many cases, it's not really the perfect solution to use for your applications, but for any modern application stack, it will support it. If you build the correct image, you will be able and utilize the APIs properly, you will be able to do that. Okay. It's not a monolith, right? Kubernetes is not a monolith. It does not have default solutions for things, right? The solutions you wanna plug in are optional. It's up to you. You can plug them as you wish, right? It gives you the building blocks, as we discussed, to add to the API, to do what you need, to utilize that API. You can also extend that API as well, but it preserves your choice. It preserves your flexibility, and that's what's important in Kubernetes. And that's the standard of Kubernetes as a cloud-native tool. I can run, typically in a best world kind of scenario. You would be able to deploy an image to a Kubernetes cluster on-prem. You can take that and deploy it to a Kubernetes cluster on Azure on an AKS cluster. It should still work. Because it's the same standard for Kubernetes. As long as the same version of Kubernetes, same API, with no dependencies on, let's say, local storage on-prem and local storage on the cloud. So if you have that kind of agnostic application, it can run anywhere, just the application itself, you will be able to deploy it. Let's say an application with the configuration and the secret, yes, so you can run it anywhere, or should be that way. That's the cloud-native standards, right? One thing to note: Kubernetes does not it does not limit, the applications that are supported. Again, as I mentioned, it aims to support any diverse variety of workloads, right? Stateless stuff, stateful things can be deployed on Kubernetes. We will get to that, right? We want to process data, you can do that on Kubernetes, right? If an application can run in a container, it would run greatly on Kubernetes, pretty much, to keep it simple. Okay. One thing that's important: Kubernetes does not build your source code. You don't take your code and put it in Kubernetes. It's not a CI/CD tool. Okay. Continuous integration, delivery, and deployment workflows like that, these are determined by your organization's culture and your preferences, and as well as your technical requirements. Right? It's not Kubernetes' role it does not replace CI/CD tools. Okay. You still need to have a CI/CD pipeline that builds your image from your code, and then it gets deployed to Kubernetes. Okay. It does not provide application-level services. And by application-level services, I mean things like middleware, message buses, for example. You can run them on Kubernetes. You can run Kafka or RabbitMQ or whatever on Kubernetes, but it does not come out of the box. It's, again, it's not a PaaS, or it's not, a SaaS solution as well that has all the components you need and you just put your code there. It doesn't work that way. Okay. It doesn't also provide like data processing frameworks. Like Spark, for example, is not out of the box there, right? Also, databases are not out of the box also on Kubernetes, like MySQL, or caching systems, or cluster storage like Ceph, or all of these. It gives you the ability to deploy them. It gives you the ability to plug with them in a really great way, but it does not provide them out of the box. So keep that in mind. Okay. They can run on Kubernetes. They can be accessed by applications run on Kubernetes, but they are not out of the box. That's important, because a lot might assume that Kubernetes is a solution for everything. You still have to plan and design your application properly. Okay. Additionally, it does not provide or adopt any specific machine configuration or maintenance or management systems. Okay. So in short, you still have, if you abstract these nodes for Kubernetes, okay, unless you're using a managed Kubernetes, and I will advise to use that, and we will get to the details of that. But if you're building your own, it does not, Kubernetes doesn't have a specific standard of how your machine should be. There are specific requirements, obviously, and prerequisites, but it does not adopt a specific standard that you have to use, for example, Red Hat machines, or only Debian, or Windows is not allowed. Windows has become supported by Kubernetes, for example. It took some time, but for the last, I think, 2 or 3 years, you can run even a Kubernetes cluster on Windows VMs as well. It doesn't have as much features as Linux, but within Linux, you have so many distributions, right? In there is no specific requirement, right? It came from Google. They didn't enforce their certain standards in there, right? Also, how you maintain these systems, how you manage these systems that are provided for Kubernetes to abstract and build on top, that's also up to you, okay? Additionally, I keep saying the Kubernetes is an orchestration system, but keep in mind, it's not a mere orchestration. It's not only an orchestration system, right? It takes away the orchestration effort from you manually. It does it on your behalf. You still have to configure it that way, right? So orchestration, as a definition, is just the execution of a defined workflow, right? You go from A, you do A first, and then B, and then C, right? Kubernetes does that on your behalf, but you have to define your desired state, right? So we will get to the details of that, but Kubernetes, if you want to think of it from a logical flow of things, it's pretty much a set of independent control processes, right? That pretty much continuously drive the current state of the system towards the desired state that you have provided. Okay, so and that orchestration is only one part of that. You have other pieces to handle, right? The next slide, I'm going to delve into the Kubernetes architecture. Okay, this is from the Kubernetes documentation as a diagram. Pretty much in Kubernetes, from a high level, as you can tell, you have your Kubernetes control plane, your Kubernetes nodes. I will delve into the details of every piece of them. But at a high level in the Kubernetes control plane, you have your API server. That's the central, as you can see, it's the center of everything. Everything flows through it. Your communication with it goes through it. The other pieces of the system also communicate through the API server. So it's like a hub and spoke kind of pattern. Okay, you have a cloud controller manager. That talks to the cloud where you're hosting your Kubernetes, like AKS, for example, on Azure. So you need something as an interface with your cloud, right? There is a kube controller manager that will manage all these, as we said, the independent controller processes, right? If I create a deployment for each one of them, there is its own controller that is managed. There is one piece in the control plane, which is the controller manager that creates these and looks at them all from a high level. There's the kube scheduler, which will send your or schedule your deployments and your workloads on the appropriate node wherever they fit. And the etcd is pretty much the data store for your state in Kubernetes. Okay, from a node perspective, on every VM you need a kube proxy, a kubelet. Additionally, you obviously need a container runtime as well. Kubernetes does not replace Docker. Kubernetes needs Docker to be there, for example, right, as a container runtime. So to delve a bit further into that piece, so for the Kubernetes control plane, as we mentioned, excuse me, it has these 5 main components. Okay, the first one is the kube API server. So this is a component of Kubernetes that exposes your Kubernetes API, that abstraction API that we spoke about. This is what you communicate with, and all the components in the cluster communicate with. Okay, the API server is the front end for your control plane. It acts as the gatekeeper to your cluster. It handles authentication, authorization, request validation, admission control. Anything that you communicate with the cluster goes through there. The main implementation of the Kubernetes API server is the kube-API server. That's what it is. It can run as a container itself, by the way. It can be containerized, or you can run it as a process or a systemd process, for example, on a Linux system as a daemon. It's your choice. Obviously, you go with a managed Kubernetes cluster. You don't care about any of this. Okay, we'll get to that part maybe in a few presentations. Okay. So it's designed to scale horizontally. Okay, so it scales by deploying more instances of that, and you're still hitting that one API endpoint, and it will be load balanced to the API server, scaled out or scaled horizontally instances, right? So you can run several instances of it and balance the traffic between them. Okay. Additionally, there is the etcd. Etcd pretty much is just a consistent and a highly available key value store. It's used as a Kubernetes backing store for all cluster data. Okay, so when I tell Kubernetes this is my desired state, that state is in etcd. At the same time, the status of the cluster is also in etcd, and the Kubernetes API will talk to the etcd and make sure that it's matching both of them all the time, continuously. Okay. And when it comes to the other part there, there's a kube scheduler. It pretty much watches for any newly created pods, and it assigns them to a node, okay, to what they call as a worker node in Kubernetes. Okay, so there are several factors that are taken into consideration there when it's scheduling anything to decide where to schedule it. It depends on the individual and the collective resource requirements, right? So let's say my pod that has my containers, or preferably one container, it needs a certain amount of resources in terms of CPU and memory. Scheduler will look for a node that has enough, resources to schedule it there. Okay, there are other factors that you can control. There are certain things you can configure through the Kubernetes API. Let's say I have a node, I have 5 nodes, 2 of them have GPUs. I want to run workloads that require GPUs, right? So I can set a node selector that will tell the schedule indirectly that when you want to deploy these pods, please choose the nodes that are labeled as they have GPUs in them. Through the API, you can control all of that. You put labels on your nodes that these nodes have GPUs, and then you tell the scheduler through your deployment template of these pods that, okay, these are labels with GPU, and they will select the node that has GPU. Excuse me. So it will deploy it to that. It will pretty much force it to that. If you have other reasoning for forcing things where they need to also be deployed, you can also control that with labels and affinity and anti-affinity. And there are a lot of components in the API, in the Kubernetes API, that allow you, a lot of properties allow you to control that scheduling. Okay, but there is a major factor, which is the resource allocation, because even if you tell it, put it on the GPU one and it's full, it will not be deployed. It will just stay there pending, not deployed anywhere till I have enough resources. Okay. The other component I mentioned is also the kube controller manager, which runs the controller processes, as I mentioned, right? So logically in Kubernetes, every deployment of pods, you don't just deploy one pod generally, and we'll get to that piece, but usually you create something called a deployment that has a replica of pods, and it will handle it for you. It will monitor, like, okay, this is the state I want. I want 3 replicas of this container or this pods. And then within it, you have your container or containers, it depends. Okay. And you will tell it, okay, this is how I want it to look like. This is the labels, all the details that I need. This is the image that will be used. This is the volumes it will have. You build a full template, right? So by default, Kubernetes will logically create separate controller processes for each, right? So that reduces the complexity. They are all, so it will take these, and for each one of them, it will have its own process monitoring that deployment, right? Everything goes through the API server eventually, of course, but it's monitored that way, right? So think of a controller as a control loop, right? The best example would be a thermostat. It just watches the state that you want, right? So you put your thermostat, I want 25 degrees Celsius, right? If it goes above 25, the air conditioning will start, and it will lower it to 25, right? If it gets to 25 or it goes below it a bit, it will stop, right? So something like that. So it's similar. So in Kubernetes terms, it's just a control loop that's watching the state that you have shared, the desired state that you want through the API server, and it makes any change in an attempt to always move the current state that is deployed, that is currently running, to match that desired state. That's how it works. Okay, so there are different controllers. They are actually all compiled into one binary, which is the kube controller manager. But some of the controllers, as an example, there's the node controller. Okay, so this would watch the nodes, the worker nodes I have. It will notice if any of them are responding or not. If anything goes down, it's out of the scheduling. Nothing will be scheduled there anymore, right? There are also controllers that handle the replication, which, as I mentioned, it's responsible for maintaining a certain number of pods, right? If I have a certain replica of pods that I want 3 replicas of this, it will keep maintaining that there are 3. If one of them goes down, it will add one. If you manually add one, it will eventually remove it and make it only 3, right? So it does that kind of control in terms of the number of replicas that I have running. Okay, there's also an endpoint controller. This one populates the endpoints, right? So as I mentioned, at a high level, Kubernetes allows you to expose your pods or your services with a DNS entry within your cluster, right? Also, you can have endpoints outside your cluster. We'll get to that piece, but in general, you have these endpoints control that you create, whether they're IPs or DNS entries or whatever. There is an endpoint controller that populates these objects with if a new service is created, it will add that to the endpoint list that, okay, I have this endpoint now available within the cluster. Right? There's also service accounts that you create and tokens. These are generally used for like some kind of automation. And whenever you create a namespace, I will get, there is a piece in this presentation about namespaces, but in there, whenever you get to that, you will cover the you get a default account in there and the default token and in every new space. There is a controller that handles that, okay? And the last piece in the control plane is the cloud controller manager. That pretty much embeds all the cloud-specific control logic, and it just lets you link your cluster with the cloud provider where you're running from an API perspective in an abstracted way. Okay, so it separates out the components that interact with the cloud platform from the components that just interact with your cluster. Okay, so it helps you keep it separate that way because it's its own component running, right? So it runs the controls that are specific for that provider. So if you're running it on premise on a learning environment on your laptop, you will probably not see it. You will not have a cloud controller manager. This is specific for clouds. Kubernetes, as I mentioned, is made in a cloud native approach, so it should work anywhere on any cloud. So to do that, they have created, there is these cloud controller managers that can abstract things for every cloud provider wherever you run it, right? So similar to the Kube controller manager, the cloud controller manager also combines several logically independent loops within the same binary, right? So for example, if you wanna, and you can also scale it horizontally if needed for performance. Again, when you're hosting on the cloud, that's done for you by the cloud pretty much, okay, as a managed service. But if you're gonna deploy your own, that's gonna be a bit more complex, and I would definitely advise against that, right? So the different controllers I would mention, there is like a node controller, again, similar. That one would check your cloud provider to see if the nodes are running, because the nodes are pretty much VMs specific to that cloud provider, right? So it needs a different kind of interface to talk to rather than on-prem or where you are controlling them, that you are manually installing or adding them to your cluster, right? There's also a controller about scaling, right? Auto scaling. This is a newer, not very new, it's been around for a while, but it's one of the newer features available in Kubernetes on the cloud specifically to do the auto scaling. So if I end up, let's say, having pending pods that need more, and if I configured my AKS cluster on Kubernetes, for example, to on Azure to have to need, like, it can go between a minimum of 5 nodes to 10, for example, and I have 5 running, and then there is a need for a 6th one because of the resources, it will scale, automatically spin up a new one for me, and then the pods can be deployed. So this goes hand in hand with the scaling of your pods, and it also the auto scaling of your nodes. You're not gonna manually intervene here. You need a system to do that. Kubernetes have plugged in all the APIs to do that automatically. The route controller also exists on the cloud because, on that underlying cloud infrastructure, you need something to manage the routes in terms of what would reach what between your nodes. They need to communicate. There's network requirements there. Again, you don't have to do that yourself. It does it for you. And same with the service, right? So if I'm gonna create a service that is external service, so externally exposed, I can pretty much end up getting a public IP on a load balancer on Azure or a private. Obviously, it's not advised to directly put a layer 4 load balancer as a public IP. It can be also an internal load balancer, and then I have a different front end with a firewall and a WAF and all of that. So, but to do that, to configure a load balancer in that specific provider to expose my service externally, you need also, there is the service controller that does that. It's a subset of the cloud controller manager, okay? And Kubernetes, so when it comes to the node components, there are 3 main components. There's the kubelet, which is an agent that runs on every node, okay? These components run on every node. They need to maintain the running pods. They provide the Kubernetes runtime environment pretty much, and the communication with the rest of the network within your cluster and with the API server. Okay, so the kubelet is just the agent running on that node and making sure that your containers are running in a pod. Because you have a container runtime, you have Docker. You can go to that node and run a Docker, run whatever container, but that's not going to be part of your cluster. It has to be through the kubelet. Okay, so in that case, the kubelet just takes a set of these pod specs that you have provided, right, and through its own mechanisms, it will ensure that these containers are that you have described as these specs are running and they are healthy. Okay, it does not manage any containers, as I mentioned, that are created that are not created by Kubernetes. So if you create something through the Kube API, it will be managed through kubelet. Otherwise, it is not. Okay. And same with Kubernetes API, it will not see any pod on that node or any container on that node that is not deployed through it, right? That's how it maintains that connectivity. Kubeproxy is pretty much a network proxy that runs on every node in your cluster, and it implements the part of Kubernetes service concept. Okay, so that handles the Kubernetes service running. It maintains the network rules in these nodes. Typically, it does it through IP tables on Linux, for example. It has the access to deal with that. And these network rules will allow the communication between, plus the overlay network that gets deployed. You need that because all the pods have to talk directly. They go through the kubeproxy if they are outside that node. Okay. So these rules, they allow the network communication to your pods from sessions inside or outside your cluster, right? So if I create a service, that also, even if it's an external load balancer, eventually it comes to a Kubernetes service, and that service will use the kubeproxy to get it to load balance it to a specific pod that's running on that node, right? Additionally, it uses the operating system, as I mentioned, the operating system packet filtering layer that's available, right? So, such as IP tables. Otherwise, it will forward its traffic itself. It can do it as well as its own process. Okay, and when it comes to Docker container runtime, as we mentioned, it's pretty much, we covered that more in details in the first presentation, but it's pretty much a software that's responsible to run your containers. So, the most famous is Docker. Kubernetes supports multiple of them. There's Docker, Containerd, Creo, as well any implementation of the Kubernetes container runtime interface. So there is a global standards that have been created for container runtime interfaces, and anything that implements that works with Kubernetes CRI will be feasible to be used as a container runtime. But typically, you will see Docker as the most used, to be honest. Okay, cluster add-ons. Okay, so add-ons to the cluster are actually not deployed as their own or part of the control plane or anything else. They actually utilize Kubernetes resources to do that. They utilize something like daemon sets or deployments. Deployments are pretty much like a group of pods. They are handled under one deployment with a certain spec. Daemon sets, I will get to these details also in the next presentation, but daemon sets pretty much make sure that there is one pod running on per node. Okay, unless you put certain filtering to choose specific nodes, but daemon set, from the name, it just makes sure you have that daemon pod running on every one of your nodes in your cluster. Okay, so they are essential to implement certain features. Okay, so they are providing cluster level features. So typically any resource that is going to be namespace that you want to deploy as an add-on, you would typically deploy it in the kube system namespace. In every cluster, you always have the kube-system namespace. We'll get to namespaces and explain about them, but that's pretty much the best practice to do. Okay. Because the kube system should not have any of your own workloads. You should have different namespaces for that. The first and most famous add-on that you need to have is the DNS. Okay, so every cluster should have its own cluster DNS within that cluster, because it's pretty much a DNS server. The most famous among them is probably Core DNS. There's also Kube DNS, but Core DNS has probably taken over in popularity. So that's going to be the DNS for every pod within your cluster. So they will use that for their resolution, but that core DNS service itself can communicate and should definitely communicate with external DNSs, with your own one on-prem or with something you have on your cloud or whatever to manage your private DNS outside the cluster, right? So the core DNS is mainly to implement it will serve the DNS records within your Kubernetes services, because everything will have a DNS record, and you can utilize these, and they're essential for workloads to run properly. Okay, so any container started by Kubernetes will automatically include this DNS server and their DNS searches. They will just use that. Okay. And it will allow the users to manage and troubleshoot any applications that are running within the cluster, as well as outside that cluster. Right? So the next add-on that you can utilize is a dashboard. It's like a web-based UI for the Kubernetes cluster. I would definitely not recommend to use that. It's not really great. It's not very secure. It doesn't support proper authentication. It's going to use a service account, which means you cannot identify what user is doing what through that. As an example, AKS actually disables the dashboard by default when you join your cluster to Azure Active Directory for authentication. So if you want to use Azure Active Directory to authenticate to your cluster and manage it through there, rather than just manage users internally in that cluster, that dashboard is disabled because it does not support something like that. You cannot use it. It will use a service account within the cluster, which means you cannot really identify or audit what's happening there. Okay. Additionally, the container monitoring add-ons, right? So this will just record generic time series metrics for your containers in a centralized database, and it will give you a UI to browse that. The most famous among that is Prometheus and Grafana. So Prometheus will scrape the data out of your pods and your containers and make it available in its DB, and Grafana can use query Prometheus to build these graphical UIs and dashboards and things like that and graphs for this. Okay, again, this is up to you to implement. As we mentioned, Kubernetes does not provide this out of the box, right? It's not like a typical PaaS. On a managed service, yes, you have some features. AKS has container insights out of the box. You just need to point it to a log analytics workspace. Okay. Additionally, another add-on is the cluster level logging. You are also, this is responsible for saving the logs in a centralized one, and you can search it and all of that. So FluentD is one of the most famous open source. Again, in a managed cluster, you don't really have to worry much about that. You can just simply enable it easily without worrying about deploying your own things and maintaining them. Okay. So Kubernetes API and objects to cover that. So the Kubernetes API, it lets you query and manipulate the state of the objects, as we discussed, right? So it's the core of yes.
Yeah, I meant this is Kader.
Yes.
There, almost it's 11:30, right? End of our session. How are we doing with your time? And also there are some questions if you want to give some time for the.
Okay, we can continue this the next. I've been presenting for 52 minutes, so I'll leave the rest for questions, and I'll continue from here the next presentation if you want. Does that make sense?
Yes, obviously.
Okay, so let's get to the questions, guys.
Sure. Just for the audience, right? In case if you're not able to answer the questions that you have that was presented this session by Ahmed, you can always ask those questions in the Microsoft Teams before and after the event. So Ahmed is always engaged to do that. Use the channel rather than sending too many questions to him on the LinkedIn. Right? Channel means everyone else can also get benefit out of that. So let's look at the questions here, Ahmed. And also, please feel free to unmute and ask if you have any specific questions.
Yeah, go ahead, because I only see one question, Kader. I see this one about containers. Mm-hmm. I would prefer to like if Patel can look at the previous presentation, maybe watch that video and go through the slides. And if he has still it's not cleared up, I can answer it. For now, I maybe to allow the live questions would be more efficient, I think. So what do you think? Like things that relate to the current. If I want, I can answer this. I don't mind. But if anyone has anything that relates to what we have presented now, I can answer that.
Yeah, Ahmed, this is Partha.
Yes.
I'm actually looking at installing Kubernetes somewhere and trying out some of the features and so on.
Yes.
And I look and I see there are two other things that can substitute for Kubernetes. One of them is Minikube.
It doesn't substitute. It's Kubernetes.
It is Kubernetes. So yes. If I install Minikube, it will give me all the features that we have just been speaking about?
Not all of them, because Minikube will not give you the ability to create a load balancer, for example. Right? It's not on a cloud. It's on your system. You need to expose a load balancer as an external one. It will not give you that. Within the cluster, yes, it will create services.
Okay.
So
the other one is Rancher or K3S.
Yes, that's another option. Generally, there is kind. I was actually one of my slides towards the end here covers that piece. So there is kind. Let me actually share the links here. Just give me a second. So for everyone's reference, I'll put it on the chat here. So this is an official guide for installing. So it starts from first step on a Windows desktop. Okay, you need to have Docker in place, and then on top of that, you can either add just run a kind cluster or Minikube. I would, if you're gonna go for Minikube, I would advise to just go with kind. Kind pretty much is like a Kubernetes in a Docker container, so it will simply pull an image and deploy a cluster for you within your system, using a simple Docker container rather than having to go through all the steps to get Minikube running. So if you want to just play around with simple Kubernetes, commands and stuff like that, and look at the objects and all of that, you can use kind as a simple one, because you will have the full API, but not all the features enabled. Same thing with Minikube. Additionally, also for everyone's reference, I will copy this other one. There is katacoda.com. So that actually has a bunch of playgrounds for many things, but mainly it started with Kubernetes, and it will have, like, I think nearly 30 different modules that you can go through that will like create a pod and create this and namespaces, and it will cover all the objects in Kubernetes, and it does it for you within their system. You don't really have, and I believe it's free. For now, O'Reilly recently acquired it. Maybe they will transform it to something paid. But as far as I know, last checked, it was free. You just have to sign up now, and you will be able to use it. It's an easy way to play around, to have a playground in the cloud. Other thing is, if you have free credits, you can set up a free account with Azure, and you can just deploy a simple AKS cluster and use that. Azure will also have the documentation to deploy a very easy one. Yeah.
Okay. Minikube, what would be the CPU and memory requirements for installing Minikube on a single system?
I'm not sure 100%. And on my end, I don't really bother much with that, because my system, I have more than 32 GB RAM, so I never really looked at the requirements. But I know Kind, for example, Kind is using around one CPU. So one thread on a regular laptop, and around 2 GB RAM. It doesn't really use much. So I would recommend to go with that.
But would that really support, let's say, if I develop an application which has at least...
No, you will not. That's the point. You cannot do it doesn't have all the features, right? You'll not develop a full application in your system with a Minikube. It's not really made for that, to be honest with you.
Okay.
It's made to just play around with the API.
Yeah. Okay. Thanks. Answered my questions.
No worries.
Top-notch, guys. Top-notch questions, top-notch presentation, Ahmed, as always. Great. We have 3 more sessions from Ahmed, so please make sure that you join next 3 sessions, same time, next week, Saturday, for next 3 weeks. I'm sure that we all will learn, and I'm very excited to continue this journey with Ahmed, to see, in next year, if we can do a little bit more deep dive into one particular topic within Kubernetes, right? So those kind of stuff will definitely explore together. And the team here, I just also want to make sure that, this community is run by the volunteers, meaning all of us. So if you have any topics to present, any particular topic that you wanted to help other people to learn, please reach out to me at testoper@testoper.com, right? Pretty simple email, you can remember, testoper@testoper.com. Share your interest if you want to take some topic, and then we can talk about it and see how we can try to bring them into the schedule, into the future schedule. So I have one question for you.
Yes.
Before we close, Ahmed, right? So there's a lot of people talk about cloud native, and then of course you also presented that Kubernetes has been given into the cloud native CNCF Foundation to take it forward and so on. So what is cloud native?
Well, everyone has their own definition, it seems, nowadays. But it's pretty much that, in short, it's just the approach of just building and running an application that takes advantage of a cloud, right? So you build an application that takes advantage of the strength of the cloud, of the features of the cloud. At the same time, also, there is another definition of it, of actually, not another, it goes hand in hand with this. At the same time, you would want to have an application that can run on any cloud. So in my honest opinion, I find these two opposing. That's why I'm saying everyone have their own definition, right? So, so for example, CNCF specifically, like the CNCF definition of cloud native, because they are the cloud native foundation, right? They pretty much define it as using open source software to have your stack containerized, and every part of your application is packed in its own container, as we mentioned, microservices, right? And you have the dynamic orchestration around it. And each part is actively scheduled and managed, and you can optimize the resource around it, and it's microservices oriented, right, from an overall agile and maintainable way of things, right? But but if you take it from let's say how cloud providers would define it, to say, okay, cloud native, yeah, you package things into containers, you do this, but you also use our cloud services. But if I use your cloud services, how do I move my workloads? You get my point, Kader? If it's gonna be in the definition of a pure cloud native, that this can run as a container that is packaged, and I can take it and put it somewhere else. But if I put it, let's say, on Azure, and I use the Azure SQL servers, right, and then I take it and put it on let's say, on Google, and I want to use some other DB from Google or AWS, and I use RDS or something. I'm not really very familiar with Google Cloud, but on AWS, there's RDS. I have to do changes, right? It's not really that portable as the Cloud Native Foundation wants it to be, right? So this is where the discussions around Cloud Native keep coming up. I personally, from an objective point of view, I would take the Cloud Native Foundation's definition of it to actually build that my application should be a container that is really, if I run it on my system, I take it and then I run it on an AKS cluster, it will run. Do you get my point? Regardless of where.
I basically, took two key points from your answer, right? So the first point is building, whether software, hardware based, embedded, whatever, right? Building some solutions or a product that can utilize bits and bytes of resources provided by the cloud.
Yes.
Point one. And then point two is portability, right? Ability to move whatever that I build across different clouds, right? And it works without any problems. These are the two key things that I could relate to the word cloud native. And now, just because cloud native CNC of cloud native foundation has taken Kubernetes, a lot of people are starting to think Kubernetes means if I use Kubernetes, then it is cloud native, right? So
no, not really. Yes, because now we covered this in the first presentation, but I can take an elephant and stuff it in a container, right? So if I take if I have an application that's legacy, it has Java and the Python and whatever, and even under Java has a million things running in there, a million processes, like 10 of them, and then I stuff all of them. I can do that. I can put it in a container. I can give it 4 cores and 10 GB of RAM, and I can put it in a cluster. It runs as a pod. But is that cloud native? It is not, because it's not microservices oriented. What I would want to add to the points you mentioned, Kader, is the piece of microservices oriented. That's very critical, because everything has. Sorry, what?
No, that could be a third takeaway. It should be microservice oriented, right?
Because under it, a lot of things go, right? If something is microservices oriented, as we covered in the first presentation, a lot of things go under that. The ability to manage it, the ability to scale it individually, all of that, the resource control that I would have on every part of it, using the right tool for the right job, right? So if I want to do data processing, I might go with Python. If I want to run an application, I might go, Java. If I want to, so that's a very powerful thing and important. And again, I typically in my day-to-day job, I see this a lot with a lot of developers. They will say, okay, well, we try to deploy something to the cluster, it doesn't work. Oh, it was working on my system. That means there's something wrong in the development that you have done, to be honest, from a cloud native perspective, right? If you give me an image, it has to run on the cluster, whatever the Kubernetes cluster is.
Understood.
So one of the extra points I would like to add is that basically the plumbing part of it must not be baked into the microservice. So that would be part of one of the requirements for the cloud.
Partha, you know what? I want you to prepare some session for us, man, on a topic of interest. You have been attending too many sessions. It's time for you to give back to the community too, Partha.
Yeah, sure. I'll do something in September.
Create some topic and let me know, and then we can talk about it and see.
Yeah, I can tell you even from now it will be on Kubernetes.
maybe after Ahmed's session, we'll plan something around that. Okay. Sure. Perfect. Guys, thanks a lot for joining. Only one ask that the Testoper community, all volunteers have, is we are doing it as a non-profit to help you guys. you also please help us in whatever capacity that you can. It could be as simple as posting about it in LinkedIn, talking to your friends, colleagues, and family to join and benefit. It could be talking to your employers to help us to sponsor, and it could be in the form of donation or whatever, right? Try to help us to grow and make this like a grassroots movement where every one of us are helping every one of us to grow in our career, entrepreneurship, and entrepreneurship goals. With that, let's close the call. Final words, Ahmed. I'll give it to you to close the call.
No, thank you, Kader. That's all. I just like to thank everyone for attending. Hopefully, we're benefiting them, and we'll continue next time from where we stopped. And yeah, more details are coming in. Sorry if I'm, I've been overwhelming with a lot of information, but I'm trying to, cover as much of the basics as possible, so you can take it on from there. Everyone has to also. I shared the link for the best resource for learning. You can feel free to start looking at it. The kubernetes.io/docs. You start from there, choose the version that you want to test with as well, and start from that point. I would really advise everyone to also, you already have the interest to join us and get this, but all we can share is the first basics, and we can delve into more details later on. But you also have to continue your eagerness with the self-learning. That's the most important part of it.
Yep, TestKeeper is all about continuous learning to become experts, right? Helping each other. That's the key message. I'm sure that in the chat, the programs team basically sent out a WhatsApp link for you guys to join the closed Codeathon group WhatsApp link. But please remember that WhatsApp is used only for the most important communication. Don't put like jobs and ask technical questions and so on, right? That's just for an important things where we can collaborate and communicate. I recommend you all to send your email addresses to create an account into this Teams, like I showed you earlier of this presentation, so you can collaborate with Ahmed before and after. He's very good in looking at it and answering and helping and guiding people to really grow in this space. With that, have a great weekend. Enjoy your time. Weather is good, but stay safe. Even though things are open, the COVID is still not safe. Take care and talk to you guys next week, same time, 10:30 a.m. Saturday. Bye-bye.
Thanks. Bye.
Bye. Thank you, everyone.
Bye.
Thank you, everyone.